Give the sum of the first 15 terms of 3, 5, 7, and 31 as the last term. Okay, so to solve this, our formula for the sum of arithmetic sequence is S sub n equals to n divided by 2, and multiply this by the sum of the first term and the last term, so or a sub n. Our n here, this is the number of terms. Our a sub 1, this is the first term, the value of the first term. And then a sub n, this is the value for this equation. This will be the value, okay? This is the value of our last term. Okay, now going to our problem. There are 15 terms. So since we know that there are 15 terms, we have here n equals to positive 15. And then for a sub 1, this is the value of our first term. Our first term is positive 3. Our a sub n, since this is our last term, so our a sub n here will be equal to a sub 15. So our n is positive 15. And then a sub 15, since this is our last term, its value is positive 31. So given these values, we can now solve for our s sub n. Again, our s sub n is equal to n all over 2 multiplied by the sum of a sub 1 plus a sub 15. Okay, so s sub n here will be n, that is 15, divided by 2, and multiply this by our a sub 1, which is positive 3, plus a sub 15, which is 31. So s sub n, or the sum of all terms, will be 7.5. Multiply this by positive 34. So we will have here 7.5 multiplied by 34. Our final answer is positive 255. So positive 255 now is the sum of all the terms of our given arithmetic sequence. And this is our final answer. Give the sum of the first 8 terms of positive 4, 9, 14, and so on. To find for the sum of an arithmetic sequence, we know that the formula is s sub n equals to n all over 2 multiplied by a sub 1 plus a sub n, or the last term. For our given problem, our n here, this is the number of terms. We have here 8 terms. So our n is equal to positive 8. And for our a sub 1, this is the value of our first term. Our first term here is positive 4. And for a sub n, this is our last term. Since we have 8 terms, our a sub n, this will be a sub 8. But we do not have, or we do not know, the value of the last term. Okay, so using this equation, we can rewrite this equation as n is equal to n all over 2 multiplied by a sub 1 plus a sub n, Or let's change the n here, since we know that this is a sub 8 already. Okay. Now, since we do not know the value of a sub 8, let's just take the equation of finding a sub 8. The equation for finding a sub 8 will be a sub 1 plus n minus 1 multiplied by d. Okay, since we know the value of n, but we do not know the value of d. Okay, so we have to find for the value of d. Okay, now since we have 3 consecutive terms here, we can find the value of d. So to find for the value of d, we will either subtract 14 and 9 or 9 and 4. Okay, so let's subtract 14 and 9. So d will be equals to 14 minus 9. So our d here is positive 5. So we can now find for the value of a sub 8, or the value of our last term. This will be equal to, our a sub 1 is positive 4. Okay, and add this by our n, which is 8 minus 1 multiplied by d, which is positive 5. So our a sub 8 here will be equal to positive 4 plus 8 minus 1, that is 7. 7 times 5 is 35. Our a sub 8 will be positive 39. Okay, since we already have the value for a sub 8, we can now solve for s sub n. Okay, let us now solve for s sub n. S sub n now will be equal to, our n is positive 8, so this will be 8 divided by 2, and multiply this by a sub 1, which is positive 4, plus our a sub 8, which is positive 39. S sub n will be equal to 8 divided by 2 is 4, multiply this by 4, plus 39, this is positive 43. Our S sub n now will be equal to 4 multiplied by positive 43, and we have positive 172. So positive 172, this is the total of all the arithmetic terms of our given arithmetic sequence, and this is our final answer. Give the sum of the first 15 terms of positive 6, positive 10, 14, and so on. The formula for finding the sum of the arithmetic sequence, we have S sub n, this is equal to n over 2 multiplied by a sub 1 plus a sub n. If there is no value for a sub n, or the last term, we can substitute the formula a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So let us check our given problem. For our given, our n here, or the number of terms, based on the statement, we have 15 terms. Our n will be positive 15. And our a sub 1 here, or the value of our first term, we have positive 6. So 6 is our a sub 1. And then our a sub n, this refers to our last term. Since we have 15 terms, our n here will be 15. This will be a sub 15. But we do not know the value of a sub 15. Okay, so since we do not know the value of a sub 15, let us find for a sub 15. we are going to use this equation. Okay, so the equation is a sub 15. This will be equal to a sub 1 plus our n. We know that n is 15 minus 1 multiplied by d. Okay, we have no value for d. We do not have the exact value for d. So we have to solve for the value of d. Our d here, this will be equal to the difference of 14 and 10, or 10 and 6. So we will just choose between the two sets. Let us choose 10 and 6. So our d will be 10 minus 6. This is equal to 4. Or, so that we can see that they have the same d, we can also subtract 14 minus 10. This is still equal to positive 4. So our d now is positive 4. Okay, so let us now substitute that value to a sub 15. So a sub 15, this will be equal to our a sub 1. Again, our a sub 1 is positive 6 plus our n, 15 minus 1. This will be equal to 14. And our d is positive 4. So our a sub 15 here, or the value of our last term, will be 6 plus, and we have here 14 multiplied by 4, that will be positive 56, and our a sub 15 is positive 62. Since we now have the value of a sub 15, we can now solve for s sub n. Okay, so our s sub n, again, this will now be s sub 15, since our n is 15. So n, this will be 15 divided by 2. Multiply this by our a sub 1. A sub 1 is positive 6 plus a sub n, or a sub 15, that is 62. S sub 15 now, this will now be equal to 15 divided by 2 is 7.5. Multiply this by positive 68. So we have 7.5 multiplied by positive 68. This will give us positive 510. So the sum of all the 15 terms is positive 510. And this is our final answer. The sum of the first 12 terms of negative 12, negative 8, negative 4, and so on is blank. So we need to find the sum of the arithmetic sequences. The formula to use for this sum is Sn, or S sub n, equals to n divided by 2, and this will be multiplied by the sum of the first term plus a sub n, or the last term. Now, if a sub n, or the value of the last term, is not given, we can also use a sub n is equal to a sub 1 plus n minus 1 multiplied by d. On our given problem, okay, our n here refers to the number of terms. So our n will be equal to, there are 12 terms, so our n is equal to 12. And a sub 1, this is the value of the first term, so our first term here is negative 12. And for our a sub n, so our a sub n here, this is also a, since our n is 12, this will be a sub 12. but we do not know the value of a sub 12, so this is our unknown. Let us now find for a sub 12. Okay, so a sub 12, this will be equal to, basing from this equation, our a sub 1 is negative 12 plus our n is 12. 12 minus 1 multiplied by d. But we do not have the value for d. So d is easy to get. We will just subtract the two consecutive terms, negative 4 and negative 8. So negative 4 minus negative 8, this will be equal to positive 4. Or we can also use negative 8 minus negative 12. So negative 8 minus negative 12, this is also equal to 4. So our d is positive 4. Since we have the value for d, we can find a sub 12. Okay, so our a sub 12 now will be equal to negative 12 plus 12 minus 1 is 11, and our d is 4. A sub 12 will be equal to negative 12 plus 11 times 4 is 44. So this will be equal to negative 12 plus 44. This will give us positive 32. Since we have the value for a sub 12, we can now use this formula. Okay, so s sub n will be equal to n divided by 2. Our n is 12. Okay, so let's not call this as n already, since we know that we have 12 terms. This will be s sub 12. So n divided by 2, this will be 12 divided by 2, and multiply this by a sub 1, which is negative 12, plus a sub 12, which is positive 32. So our S12, or the sum of 12 terms, will be 12 divided by 2, that is 6. And then we have here positive 32 minus 12, that will give us positive 20. So 6 multiplied by positive 20 is positive 120. So our sum of all terms is now positive 120. And this is our final answer. What is the sum of the first 20 terms of positive 1, negative 4, negative 9, and so on? To find for the sum of the arithmetic sequence, the formula that we need to use is Sn equals to the number of terms divided by 2 multiplied by the value of the first term plus the value of the last term. And if the value of the last term is not given, we need to use a sub n is equal to a sub 1 plus n minus 1 multiplied by d. Okay, going to our given. Our n here, or the number of terms, this is equal to, based on the problem, there are 20 terms. So our n here will be equal to 20. And for our a sub 1, the value of a sub 1, based on the given, it is positive 1. So we have here positive 1. And a sub n, this is also equal to a sub 20, since our n is equal to 20. Now, we do not have the value for a sub 20, so this is the unknown. We first need to find for the value of a sub n. So we are going to use this equation. A sub n, our n is 20. This will be equal to a sub 1. Our value for the first term is positive 1, plus n, our n here is 20 minus 1 multiplied by d, or the common difference. We do not have yet the value for d. So to solve for d, we will just subtract. Subtract negative 9 and negative 4. So negative 9 minus negative 4, this will be equal to negative 5. Or we can subtract also negative 4 and positive 1. So negative 4 minus positive 1. And this is still equal to negative 5. We now have the value for d, which is negative 5. We can solve for a sub 20. So a sub 20, this will be equal to 1 plus 20 minus 1 is 19, multiplied by d, which is negative 5. So our a sub 20 here will be equal to 1, okay? And positive multiplied by negative, this will be negative. So 19 multiplied by 5, this is negative 95. So our a sub 20 now will be equal to 1 minus 95. This is negative 94. Okay. So we have the value for negative, or a sub 20. We can now find for the value of s sub n. S sub n here, or s sub 20 rather. So our s sub 20 will be equal to 20 divided by 2, and then multiply this by our first term. What is our first term? Our first term is positive 1. So this will be multiplied by 1 plus our last term. What is our last term? Negative 94. So this will be 1 plus negative 94. So our sum of all terms will be 20 divided by 2 is 10. Multiply this by 1 plus negative 94. This will be negative 93. So the sum of all terms now will be 10 multiplied by 93. This will be negative 930. So therefore, the sum of all 20 terms of the given is negative 930. And this is our final answer.